Welcome back, everybody. We're going to take a look today at lighting inside of Unreal Engine. It's a very deep topic, so there'll probably be a couple videos I'll put out on this, and maybe some more we'll revisit later for some advanced specialized topics. But right now, I just want to introduce you to the primary elements that are going to be ubiquitous pretty much across all engines with lighting. And we're going to start off with the simplest of lights, the point light. To be able to add a light into the scene inside of Unreal, you can come up to the placement drop down here where you go to the place actors panel, or you can grab lights from this panel here. Once you grab them, just take a point light, click and drag it out into the environment like I've done with this one, or you can right click and say place actor. If you have a recently placed light, it'll show up. Then of course, the lights are one of the more prominent elements to be added to the scene, so they have a few added here through the quick context menu. Once you add a light into the scene, you'll notice a few things. That it has a sphere around it, and this sphere is an indication of the attenuation radius, meaning the edge of its area of influence. So at the extent of this sphere, the light no longer will cast any effect onto the world. It'll stop being calculated on things outside of its range. You have the intensity here. This is measured in candelas by default, but can also be measured in a unitless value in lumens, which is the average intensity as opposed to or average brightness as opposed to candelas, which is intensity. And then there's exposure values and nits. I should mention that in this video, I have disabled auto exposure in my viewport. I just went down to perspective here at the top, and I chose, rather than use the game settings, which you'll see will modify the lighting over time to make it appear brighter, I just turned the EV down to -3 to give myself a baseline. And if you want to have static lighting inside of your level, and I don't mean static as in pre-computed, but static as in lighting that does not change as the player moves through the environment, then you can also turn that off in the project settings or by using a post-process volume. Right now, we're going to look at the details of our light here. Our point light can be added. We can move it around. Rotating a point light doesn't actually matter because its radius is omnidirectional, so we don't have any consideration for orientation in its transform, and the scale also doesn't matter because it's going to be uniform to that attenuation radius. So the only thing that really matters in terms of the transform for the light is the location. You'll notice also that for the lights, there's static, stationary, and movable. Movable is fully runtime lighting, meaning that you're putting all the computing for that off onto the computer of whoever's going to be playing the game. A fully static light is fully pre-computed, which means that you're going to spend time on the developer side. Every time you want to finalize the lighting, you can run through a higher quality lighting solution and then bake that into some files, and those get basically painted onto the world. It's not as dynamic because it can't change over time, but it does allow you to have higher quality lighting at a lower cost, and it's certainly more performant for the people who have a lower tier system. Definitely a good option if you're going to be doing mobile development. Stationary lights afford you some benefits of both worlds, but still are limited. Stationary lights cannot move, but they can have parametric changes in terms of how they can affect the world. So maybe changing the color or intensity over time, a few other parameters can be modified with that. So this is set to stationary right now, and we're not going to get into the differences between how to build those different types of lighting, just looking at the sources, but you should know that this is where you're going to set that for each light. As we go down a little bit, we have a few other categories here, and I'm going to jump to a different area inside of our scene here. We have a few blocks of material on the wall here. I have a floor that has like a shiny wet gravel, and then we have these two lights in front of us. This light here is not casting a shadow on our translucent material, and this isn't a shortcoming of our light. This is a shortcoming of the material. So if you want to have your lights cast shadows through translucent materials, you're going to need to go to, if they have it enabled, but cast dynamic shadows as masked. Once you do that, if you save this, it's more costly, but you can see this is now casting a shadow on that material. So if that's something that is important for your game, then of course you can control that just through the material design. You also notice that I can see the light reflected on the floor here. This is a specular value. So if I went into the material here for the red floor, I have this ability to control the roughness. So if I change the roughness value all the way up, then this is going to neutralize my specular value. If I went into a material, if I undo this and I go into the material itself, there's going to be a specular level that we can control as well. So the roughness, the higher the roughness, the lower the intentional or the intrinsic specular, but if you have some roughness but not maximum, then you can control specular and roughness separately, and they do actually affect different things from a rendering standpoint. But I can see that on the light here. If there's just one light that you want to have that adds an environmental aspect to the world, for example, I have this light and maybe I don't want it to cast shadows, I just want it to brighten up the environment, and I don't want the player to see that that light exists there, then what I can do is go down to the advanced options under the light, and I should be able to find the specular scale and just drop that down to 0, and you can see the light's presence evaporates from the world, and we can still have the light brightening up the scene and adding content to the space. I have this red light over here, and you'll notice that as I select it, I have this little capsule shape to it, and this is a byproduct of using the soft source radius and the soft source length. So basically making a lightsaber effect here, not to be copyright DMCA'd, but I have the idea of making a light source that has a beam that can have larger than a finite point, and I can expand that out and I can increase the radius of that thing to reflect whatever the original source is, and then the soft source radius basically adds a gradient fall off to that, so it can disperse that over a wider area. So playing with that a little bit can get you a better representation of a light source, maybe like a fluorescent light you want to have on the ground, and you'll notice that the specular value on the ground is respecting that value. And then we also have the idea that there are shadowed lights that cast color. So here I have a red light, but if I wanted to cast a light that was maybe respective of something in the environment, what I can do is go to shift to a unlit mode, Alt-3, and then this is the raw color of this material. If I hold down Control L and I click here, it's going to generate a light. And then when I click off of it, it should have the light color that reflects this object. So when I go back to the lit mode, you'll see that this light is basically neutralizing the red that was being cast from the other one. And so this light is very blue, or at least it should be, in the way that we're casting it into the environment. So if we wanted to, we could sample whatever light source that we had and then use that as the indicator for how bright the light should be. There's another way to interact with lights. If you wanted to have a point light, but maybe get the light from a source and have the point light be a little less direct, we could have a material. I made one here that just has a little emissive effect, and you'll notice that the emissiveness inside of Unreal, if you're using the Lumen real-time lighting, will actually cast light onto the environment because it's screen space lighting. So if I go a little bit off screen here, you'll see that the green actually is very present right here, and then kind of goes away when I jump just a little bit over because it's no longer being considered in screen space evaluation. So point light's useful, but there's other options, and you can of course mix and match these to do different types of lighting solutions. The next thing that we want to do is look at the spotlights inside of Unreal Engine. So a spotlight is the next option that we have to drop down here, and we can add one of these in the environment. And as I move this around, you'll notice that it looks differently than the point light by the outlines that it has here. It still has an attenuation radius. So this further extent to the bottom of this kind of bell shape here is as far as it'll go. If I extend the attenuation radius, it'll extend the light into that space. What I actually probably want to do is increase the intensity of this light, and then that extent will not be as necessary to get the light to show up where I want it to be. The point light definitely matters in contrast to the spotlight. The point light doesn't concern itself with orientation, whereas the spotlight is definitely concerned with orientation. We have orientation, and then again, scale is going to be irrelevant to the point light. It doesn't make any difference because we're using the attenuation radiuses in terms of how we frame it into the world. With this light, we have one set of variables that are different than the other one. We have the inner cone angle, which is where the hotspot is, basically the maximum light intensity. And then we have the outer cone angle, which is to the extent that it will shine light where it has that little fall off. For both the point light and the spotlight, if we go down to advanced, we have the option to modify the way that it uses fall off. So if we wanted to change it from inverse square fall off, which is what it has by default, we can make it higher. So it's using a a very high exponent, so it's dropping off very quickly. We can drop it down low, so it's very slow to drop off. And while the slider only goes down to 2, you can actually come in here and enter 0 to give you the lowest possible value of 0.0001. And when you do that, if you have the hotspot where the edge of the small and the large one go, you get this perfectly crisp line, which for stylized lighting could be useful without having to get a shader in there to start to remap the cell tones. So just be mindful that the spotlight has a few options in the way that can be implemented. We also have the ability to work with a Rect Light. The Rect Light we have is a special kind of light inside of Unreal that solves a very specific problem. So when you select the Rect Light, you'll notice that it has a radius around it. This is its attenuation radius, but its helper looks a little different. And so bring this into prominence here. The helper has 2 things that we're concerned with: the dimensions of the thing, height and width, and they affect what you think they would affect. And then we have these barn doors. The barn door in length are these little frames that are on the outside, and then the angle is how far that is going to be framing the light to be shown in front of the object. So if I have the barn doors here, I can increase or decrease the light. And of course, the angulation on this matters, unlike the point light. If I wanted to, I could put this right up against the wall and it would get me a nice clean shadow for where that light was interacting with the wall, only coming straight down from the rectangle. The middle of that area, not the barn door frame, is where the lights emanate from. The barn door is just controlling where that light is being shown to. So this is a representation of a light that's being put into a space that's framed exactly within the windowsill. This is that same light with the barn door length set to 0. And kill this one out of here. And then this one is in a recessed one that has the barn door length set very largely, and then we could see how that can project all the way over into the wall, because the light is basically being bounced around inside of this this funnel as it comes over here. And so we don't have the soft light being bounced around on this side like we do with the other 2 lights. It's being projected all the way down over here. Next kind of light that we're going to look at is the directional light. So I'm going to drag one of these into the scene here. The directional light is the opposite of the point light. Where a point light is concerned with location only, a directional light is concerned with rotation only. The directional light can be rotated to affect light in the entire scene as if it were representing a celestial body. So the idea that it is the sun or the moon or something very intense and high above. So if you have a scene that has a lot of lighting that goes into the outdoor space, this is what you're going to be using. Typically, you have one of them in the scene at a time. And as I said, location does not matter. I can put this below the floor and it shines just as brightly as it does above the floor. This represents a light source that is effectively infinitely far away, providing a uniform lighting distribution across the surfaces in the angle that it is showing. Obviously, objects are receiving the light and casting shadows, but from infinitely far away. So with these things, so we can affect the color and things like that and try to work out what sunset would be, and that could be fun. But we actually have a tool inside of Unreal to help us do that. We can interact with the environment a little bit more interestingly with the directional light if we add a sky atmosphere. So this is one of the elements that we have inside of Unreal to help us build a world that's a little more plausible. So if I click and drag this out in the environment, you can see immediately I have a blue sky, and right up there I can actually see where the sun is located. So if I select the directional light and I rotate it, you can see that distant light disk falling down, and as it gets lower into the atmosphere, you can see that it's changing to this orangish color for sunset. So that's giving us the opportunity to control day and night. Now, once it goes past the horizon, it doesn't actually bring up a nighttime reflective sky because we don't have a reflective celestial body, but the idea that we have this kind of parameter effect with the sky atmosphere to be able to say, you know, how big is the radius of the planet that it's simulating to get some sort of distant curvature to the sky it's representing, and the fact that it has this built-in natural gradient based off of the coloring of the sky, the Rayleigh scattering values that we're passing into it. It's a pretty handy thing to have just built into the engine. And of course, the intensity is controllable there. The source angle, we can increase the angle that it's affecting from where it's hitting. And then you can see that kind of gives us a bigger hotspot depending on how we have this configured. The soft angle, of course, gives us that gradient around it to see if we want a really bright disk or not. And then I think we have the ability inside of the sky to show the sun disk. It's one of the checkboxes there. You can fiddle around with those options. To make this a little bit more interesting after this, what we're going to do is we're going to make it so these shadows aren't as harsh, because when the sun's entering into a scene, we should actually expect that these shadows are going to have some ambient light reflecting back up into them. And so this is where we're going to reach into one of our other lights that isn't actually a light source, but is a light calculation. The skylight is going to grab a amount of light that's in the scene and reflect it back into the scene to give it kind of an ambient glow. So if I have the sun is casting this light down without the skylight, I get these really harsh shadows, and then with the skylight, it's going to soften those up. But if I decide that's too high, then I can reduce the intensity of that down to something more manageable, right? And so you can control that. If it's set to movable and dynamic, you can control that in real time. There's a number of options that you can do to adjust with this, ambient occlusion and things like that. If we wanted to set up the sun disk here to have light shafts and things like that, we could do light shaft occlusion and light shaft bloom, and we can kind of get these God rays coming through the windows. So fun things that you can set up with the skylight and the directional light and the sky atmosphere. In addition to these, there's a few other things that we normally get in, and really this is kind of a collection that Unreal recognizes people are going to use these resources together often, so they've given us a tool to enable these things and use them even more effectively. We're going to go up to Window and Environmental Light Mixer, and you'll see that there's a Create Volumetric Cloud and Create Height Cloud here as well, and you can see controls for the sky atmosphere, the skylight, and the directional light. If you haven't watched any of my previous videos, then you may not have seen me use this, but if I delete these three objects, they're just not present inside of the scene. I can come up to that Environmental Light Mixer, wrong button, and when I get there, you'll see that there's a Create Skylight, Directional Light, Sky Atmosphere, and then the two that we just mentioned. So if I click each one of these buttons, it will add one of those elements to the scene for each of these representations. And so this gives us not only height fog to give us the atmosphere in the space below where the sky is being drawn, but also clouds being drawn up above that are being rendered in real time, and they're deforming and moving across the sky. So if you want to control any of the properties that go along with those, we have the ability to look at the key factors in the minimal view, or we can show the normal view of the regular pieces, or we can have all of the enhanced and advanced attributes shown, and that'll give us even more control over the scene with just one menu. I can take this and likely dock it onto a second screen and just play around with these numbers until I get it to look the way that I want. So there's a lot of options with what you can do in Unreal. We've taken a look at the point lights, the spotlights, the rect lights, the directional light, the skylight, and of course some of the atmosphere and fog attributes that we've just looked at here. Hopefully this gets you an idea of how you can begin to show the details of your environment, and that you can figure out what ways you can modify the scene to best portray the lighting scenario that fits the mood of your game. I hope that it gives you enough information to go out there and keep building.